Hello, good morning my dear students, and once again, welcome to the world of electronics. Our lesson for today is a sequence of lesson 1 of module 2 under LX111, which is electronic devices, instruments, and circuits. The lesson tackles all about voltmeter and ammeter DC. Voltmeter is a test instrument designed to measure voltages in volt, millivolt, and microvolt, while ammeter is a test instrument designed to measure current in ampere, milliampere, and microamperes. So, when dealing with these two meters, we have to focus at this meter scale using these values or numbers that correspond to the ranges of both voltmeter and ammeter. However, before you attempt to use the multitester, specifically the voltmeter and ammeter, you have to check first the condition of your multitester. You have to first observe the position of your deflection pointer or deflection needle. The pointer should be set to 0 scale or infinite position for the ohmmeter scale. You notice, class, that the deflection pointer doesn't position to the 0 scale. It is a little bit advanced, just like this. It should be here. No, not this one here, not this one here. It should be here, because it will cause error in the reading of current and voltages. So what shall you do? First is to set the 0 set screw with the aid of this minus screwdriver. Just insert this minus screwdriver to the slotted head of the screw set, just like this. Rotate this one clockwise or counterclockwise to set the deflection pointer at 0 scale, just like that, to obtain accurate reading of voltages and currents. When dealing with this voltmeter, of course, we have to focus at this meter scale. Okay? There are 1, 2, 3, 4, 5, 6, 7. There are 7 voltmeter ranges. The highest range is 1000 volts. Okay, let us start from the 1000 volts range. So, we have to consider 10 as 1000 in this case. Kasi wala nang iba pang number na magagawa nating 1000 except 10. So, we have to read this 10 as 1000 volts. So, if this is 1000, this is now 800. Then, this is 600 volts, 400 volts, 200 volts, and 0. For the major divisions. And we have here the minor divisions with no indicated values. For the other major divisions, such as this one, it is between 800 and 1000. So we can consider this, or we can analyze this as 900, 700, 500, 300, and 100. So, what should be the value for every division? Or what is the calibration of this voltmeter range 1000? So, if we are going to count the number of divisions, actually there are 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. There are 50 divisions in this meter scale for voltmeter and ammeter DC. So, 1000 volt range divided by the number of divisions, which is 50, the product is, or the quotient is 20. So, meaning to say, ang halaga ng bawat guhit dito ay 20 volts when using 1000. 0, 20, 40, 60, 80, 100, 120, 140, 160, 180, 200 volts. So on and so forth. until it reaches to 1,000. Remember, when using 1,000, you have to read this 10 as 1,000, 900, 800, 700, 600, 500, 400, 300, 200, 100. Just like that. Okay? Meaning, when using 1,000, the highest voltage or the maximum voltage that could be measured by this range is 1,000. Here. And the lowest voltage is 20 volts. 20 volts. Okay? When the pointer position to this meter scale over here, that is 400, 500, 520, 540 volts. It reads as 540 volts. Or, if it is positioned here, remember, 1,000, 800, 600, 400, 200. Then the value for every division or ang halaga ng bawat guhit yan ay 20. So this is read as 220 volts. Diba? 220 volts. But if it happens that the pointer position at that meter scale, so that is actually between 400 and 500. So the value for every division is 20. 40, 400, 420, 440, 460. It is just between 440 and 460, and that is 450 volts. Or it depends on your reading for the position of the pointer. Because sometimes it is not positioned to almost middle. It is sometimes positioned lower, closer to 440. So you can read that one as 400, let us say 405. No? 405. Because this is 400, this is 460. So, just lower, just estimate. We are only up to estimation. There is no accurate reading in this case because we are using analog multimeter. Okay? Basta, here is 440 and 460. So, over here is 450. Di ba? Because this is 500. So, your reading might be 400 to 460. You may have 455, 406, 456, just like that. We are only up to estimation. Okay. Now, let us come to 250 volts. 250. So, we have heard to 250. 200, 150, 150. 0. So, this is read as 250. 200. Between 200 and 250 is 225. Diba? Between 200 and 250 is 225. Between 150 and 200 is 175. Between 100 and 150 is 125. Between 50 and 100 volts is 175. Between 50 and 0 is 25 volts. So without using calculation or computation, we can analyze it easily. So, if this is 25, this is 20, 15, 10, 5. So, the calibration is 5 volts. Or ang halaga ng bawat guhit dyan. Or by computation, calibration is equal to the range over the number of division. That is, 250 as the range, divided by 50, the quotient there is 5. So that is the way how we get the calibration. Okay, so, meaning, if we are at 250, this should be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. That's why we have here 50. 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. So on and so forth until it reaches to 250. Meaning with this range 250 volts, the maximum voltage that could be measured by that range is up to 250 only. Because if the amount of the voltage in the circuit, for example, in that electronic TV board, is around 280 volts, so you can't use this 250. The movement of the deflection filter is exceeding the meter scale, just like this. For example, we have here a battery. Then, we know that the voltage of this battery is 9 volts. Then, if you are going to use 50 volts, the maximum voltage there that can be measured is 50. Diba? So, it goes like this. Just like that. No? It is somewhere here. We are using 50 volts range. So, we have to focus on this 50, 40, 30, 20, 10. That is somewhere here. So, it is closer to 10. That is 9 volts. But if we are using 10, so the maximum voltage that could be read there is 10. Okay? Let us try using this 10 volts here. So almost 0. But remember, you have to choose a range wherein the pointer is almost at the middle scale for easier reading, and the accurate reading is also there. But if we are using 2.5 volt range, so it goes like this, class. Look at this. So it exceeds the meter scale. It will cause partial damages at the internal circuit, because we have heard actually the internal circuit of your multi-tester. No? Sorry. We have heard the internal circuit of your multimeter. The circuit is using surface mount devices. We have heard the surface mount devices, the chip resistor, the chip capacitor, the chip diode. They are called as SMD or surface mount devices because they are mounted at the solder side of this board. So they are being miniaturized. They are very sensitive to excessive amount of current. No? Once the pointer exceeds the meter scale, meaning to say that there is a large amount of current circulating there. So it will cause partial damages of your multitester. Your multitester probably will no longer indicate accurate measurement in that case. So be careful in using ranges. Okay? So it goes like that, class. So 250. Using this one because we are at 250. This is 225 because between 200 and 250 is 225. Between 150 and 200 is 175. Between 100 and 150 is 125. Between 50 and 100 is 75 volts. Between 50 and 0 is 25. So this is 5, 10, 15, 15, 20, 25, 30, 35, 40, 45, 50. 50 volts, so on and so forth, until it reaches to 250. But remember, with the range, the maximum voltage that could be read or measured is only up to 250. Beyond that, you have to use 1000 volts. Okay? Now, let us proceed to 50. So, we have 50 here. Since there are 50 divisions here, the calibration for every division is 1. Because calibration is equal to the range over the number of divisions. So the range you are using now is 50 divided by 50 as the number of divisions. The quotient there is 1. Meaning to say 1 volts for every division. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. so on and so forth, up to 50. Okay? If the pointer is positioned here, for example, you have to focus at this meter scale. Then you are using 50 here. So 30, 31, 32. That is 32 volts. Or if it is somewhere here, for example, at the middle, because frequently when measuring voltages, the pointer doesn't always position to the divisions. They sometimes deviate from the pointer, from that division. So it goes like this. Let us say it is now at the middle. So this is 30, 35, because this is 40, 35, 36, 37. So between 36 and 37 is 36.5. Or if it is a little bit higher from the center, you can have, because this is 35, 36, 37, 36.1, 36.2, 36.3, just like that. We are only up to estimation. That depends upon the clarity of your eyes. Okay? Kapag ang linaw ng mga mata nyo ay sing linaw ng mga mata ko, yan ang mangyayari, class. Okay? So, let us now proceed to 10 volts. Because the most frequently used ranges when dealing with analog multimeter, the most frequently used are 250, 50, and 10. Okay? With 10, we have here 10. So this is 10, this is 8, 6, 4, 2, 0. So between 0 and 2 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? That is the way how we read the meter scale. But looking for the value for every division, and that is the calibration, this should be, if this is 10, this is 5. Oh, if this is 2, this is 1, di ba? Because we are now at 10 volts range. Okay? 10, 8, 6, 4, 2. This is 1. Between 0 and 2 is 1. So, meaning to say, the calibration here, or the value for every division is 0.2. 0.2, 0.4, 0.6, 0.8, 1. 1.2, 1.4, 1.6, 1.8, 2. So on and so forth. Okay? Or, how to get the calibration is by dividing the range 10 volts by the number of division. That is 10 divided by 50 is 0.2. So 0.2 volts. So, if the pointer deflects at this pointer, at this meter scale, focus at 10 volts because we are at 10 volts range here. So this is 5, this is 6, di ba? Between 6 and 4 is 5. So, this is 5.2 volts. 5.2 volts. Okay? Or, if it happens that the pointer position to that meter scale, so 8 and 6, so this is 7. 7.2, 7.4. Between 7.2 and 7.4, between 7.2 and 7.4 is 7.3. Okay? 7.3 volts. Okay. Now, let us proceed to 2.5. 2.5 range. Okay? We have here 250. We must read that one as 2.5. Okay? Read this one as 2.5 because the range selector switch is positioned to 2.5. So, 250 is read as 2.5, 2, 1.5, 1.5. So, between 0 and 0.5 is 0.25. Diba? Then we have here, between 0.5 and 1 is 0.75. Between 1 and 1.5 is 1.25. Between 1.5 and 2 is 1.75. Between 2 and 2.5 is 2.25 volts. Now we are getting complicated. No? It is a little bit integrated na. Because we are using already the decimal point. Okay? So meaning, Because the range is 2.5 divided by the number of division, the result is 0.05. The meaning to say that the calibration is 0.05 or ang halaga ng bawat weight. So focus at these numbers we have here. So between 0.5 and 0 is 0.25, 0.2, 0.15, 0.10, 0.05. This is 0.05. Below 0.1 is 0.05, di ba? Kalahati ng 0.1 is 0.05. So, this should be 0. Then, we have here 0, 0.05. Then, 0.10, 0.15, 0.2, 0.25, 0.3, 0.35, 0.4, 0.45, 0.5. So on and so forth until it reaches to 200 it reaches to 2.5 volts. Meaning to say, with the trends, the maximum voltage that could be measured is only up to 2.5 volts. If the amount of the voltage here is 9 volts, you can't use that range as it exceeds the deflection of the pointer of the meter scale. It might cause partial damages at the internal circuit of the multitester. Okay? So, if the pointer is positioned here, then you are using 2.5 to 1.5. 1.5 plus 0.05 is 1.55. No? Because this is 1.5 plus 0.05. Because the calibration, no? Oh, this is a 1.55, 1.6, 1.65, 1.7, 1.75, 1.8, 1.85, 1.9, 1.35, 2. Because 1.35 plus 0.05 is 2. Okay? Anyway, hindi naman masyadong mahirap yan. Nangangailangan tayo ng constant reading, constant practice. Sa kalaunan, makukuha nyo rin yan. Huwag kayong mag-alala. Oh? Hindi kayo tatanda, kagaya ko, di ba? I am retiring, but look at my face. Sige. If the pointer is somewhere here, at the middle. So, 2.5 to 1.5, 1.5. This is 0.75, remember? Or, if this is 0.5, this is 0.55. Because 0.5 plus 0.05 as the calibration is 0.55, 0.6, 0.65, 0.7. Between 0.65 and 0.7 is 0.675. 0.625. Because kalahati ng 0.05 is 0.025. So, pero 0.025. So, this is 0.5, 0.55, 0.6, 0.65. 0.65 plus 0.025 is how much? Because this is 0.55, 0.6, 0.65, 0.7. So, 0.65 plus 0.025 is how much? Okay? Okay, we're going to use calculator. So, by this case, at this time, we need calculator. Okay? So, this is 0.55, 0.5, 0.55, 0.6, 0.65, 0.7. So, 0.65, 0.65 plus 0.25. Kalahati ng 0.05 is 0.025, di ba? Okay, let us So this is 0.5, 0.55, 0.6, 0.65. So 0.65 plus 0.025. Kalahati kasi ng 0.05 is 0.0 plus 0.025 is equal to 0.675. That is a little bit complicated, but it is up to your estimation only. Between 0.65 and 0.7 is somewhere at that 0.675 or 0.676, 0.674 or 0.677, just like that. We are only up to estimation, unlike the digital voltmeter, no? Unlike the digital voltmeter. So, there's a need of practice reading, okay, of course. Now, let us proceed to 0.5. Anyway, these ranges here are seldom used. We will refer it to the digital multitester, okay? So, if we have 0.5, we have to read this as 0.5, 0.4, 0.3, 0.2, 0.1. Between 0 and 0.1 is 0.05. Between 0.1 and 0.2 is 0.15. Between 0.2 and 0.3 is what? Between 0.2 and 0.3 is 0.25, di ba? Then between 0.3 and 0.4 is 0.35. Between 0.4 and 0.5 is 0.45, just like that. So the calibration for every division is what? The calibration here, okay. So we have the calibration 0.5 divided by 50. The result is 0.01. 0.01 volt as the calibration for every division. Okay? Meaning, 0.1, 0.2, 0.3, 0.4. Sorry, there's a little fault. Because this is 0.5, 0.4, 0.3, 0.2, 0.1. This is 0.05. So, meaning to say, this is 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09, then 0.1, 0.11, 0.12, 0.13, just like that. Okay? So on and so forth. And the maximum voltage that could be measured here is 0.5 only. If the amount of the voltage that you are going to measure is beyond that voltage, let us say 1 volt, so you can no longer use that one. So you have to move to 2.5 or more. And the last range, which is the lowest range, is 0.1. So 10 should be read as 0.1. This is, if this is 0.1, this is 0.08, 0.06, 0.04, 0.02. Okay? So there are my major divisions without value. So between 0.02 and 0 is 0.01, 0.03, 0.05, 0.07, 0.09. And the maximum there is 0.1. That is very low range of voltages. That the maximum voltage that could be measured by this range is up to only 0.1 volt. Okay? That's all for the voltmeter. Then, how do you use voltmeter when testing voltages in the circuit? So we have here. Okay, we have here 2 resistors which are connected in series. So we are going to connect this to a battery. Okay, it goes like that. So anyway, resistors are non-polarized. You can connect the battery at opposite polarity, either here or here, no? So this should be negative because we are using black. Black as the symbol for negative and red as the symbol of positive. We have here. Okay? How do we measure the voltage? Let us say we have to use 10 volts. For we knew that the amount of the voltage here is 9 volts. But if you are not sure yet with the amount of the voltage, the proper procedure here is to start at the highest range. Because if you directly proceed to the lowest range, it may cause partial damage because you do not know that the amount of the voltage here is a little bit higher than the range that you are using. So, set it to, let us say, 2.5. Okay, let us try 2.5. Okay, remember, in using voltmeter, this is positive. And this should be negative. Okay, it goes like this. It exceeds. The pointer exceeds the meter scale. Meaning to say that the range there is lower. Let us use 10 volts range. We are now at 10 volts range. Okay? Your two test rods just be connected. Just connect them across the component that you are going to test. So we have here, the voltage is 2.2, 2.4, 2.5 because it is somewhere here. You are using 10 volts. So 10, 8, 6, 4, 2. 2.2, 2.4, 2.6. It is between 2.4 and 2.6. That is 2.5 volts. Because if it is inverted in polarity, the pointer moves at opposite direction, just like this. Oh, look at that one now. The negative test rod of your voltmeter is connected to the positive side. That is inverted polarity. The pointer moves at opposite direction. So meaning to say, that indicates that your polarity is not in correct polarity with the power supply. So it should be like this. Okay? Just like that. Oh. Okay. That's the way how you connect your test rods when measuring voltages. Just across the component that you are going to test. No? Okay, class. Alright, class. Hanggang diyan lang muna tayo kasi we are out of time na. So, by next meeting, we will proceed to ammeter. No? Reading the meter scale of the same meter scale that you are going to use. Because this meter scale is both for voltmeter and ammeter DC. Okay? So, huwag kapitaan, probably bukas ay magkakaroon na naman tayo ng discussion tungkol sa multimeter. Okay, class? Thank you and so long.